Welcome, everyone. Welcome to Building HTTP Services with ASP .NET Web API. My name is Daniel Roth. I'm a Senior Program Manager on the ASP .NET team. And today we're going to talk about three things. We're going to talk about what is a Web API, why it's likely that you may want to build such a thing, and how you can use ASP .NET Web API to make it easy to build these kinds of HTTP services. So what is a Web API? First and foremost, a Web API is an HTTP service. The protocol in question is HTTP. You're trying to expose data or functionality over the HTTP protocol. Typically, your Web APIs are designed to achieve broad reach. That means you're trying to reach as many different kinds of clients as you possibly can. These clients could be browsers. These clients could be mobile devices, phones, tablets, or they could even be more exotic hardware like set-top boxes for TVs, various kinds of appliances. The one thing that all of these different kinds of clients have in common is that they all can speak HTTP. And so building Web APIs gives you great reach. And lastly, when you're building a Web API, you're typically trying to use HTTP as an application level protocol, honestly, as it was intended. This is different than, say, from a web service, where a web service is actually using HTTP mostly as a transport to move around SOAP messages, and then the actions that you're actually trying to perform are encoded somehow in those SOAP messages as SOAP actions. With web APIs, your actions actually are get, post, put, delete. You're trying to leverage the HTTP protocol to its fullest, to leverage intermediaries, leverage caching, to use HTTP for your application semantics. Now, why would you want to build such a thing? There's actually been quite a bit of attention around building Web APIs recently. There's been a lot more Web APIs built. Think the Twitter APIs, the Facebook APIs, Amazon affiliate APIs. There are a lot more Web APIs out there available publicly on the internet. Also, there are quite a few more that are showing up in the enterprise. Enterprise is finding a lot of use for building Web APIs as well. I think there are three reasons why this is happening. The first is that you need to be able to reach more of these clients. There are more devices out there. There are phones, tablets. Maybe some of you have had the experience of your boss coming to your office and saying, hey, I love the new website. The functionality is great, but can you make it work on my phone? Web APIs allow you to take the same business logic and data and expose it to all of those clients. Now that you have so many more clients, scale becomes even more important. And with the cloud, you have unprecedented access to scalable infrastructure. You can just go to Azure, you can spin up some VMs, you can get elastic scale, and that's great. But to really take advantage of scalable architecture, you're still going to need a scalable infrastructure. You're still going to need a scalable architecture for your application so you can actually scale. The REST architectural style in particular has received a lot of attention as a way to achieve scale, basically because it's the architectural style that's used by the web, and the web scales pretty well. And lastly, there's just been a trend to embrace HTTP, to simplify. If you don't need an extra layer in your protocol stack, then maybe just remove it so that things are a lot simpler. Take advantage of the HTTP protocol so that you can get the benefits that HTTP provides, the various semantics of the verbs, the infrastructure, and so forth. So let me show you an example of what an app that's using a Web API might look like. This is a simple contact manager application. The idea behind this app is that you're managing a list of people that you know. And I actually have two different clients for this app. This is a browser. This is IE. This particular app was built using ASP.NET MVC4. So these are Razor views. Actually, most of the rendering in this app is done client-side using the Knockout.js JavaScript library. And it's just going back to a back-end Web API to pull down data that it's rendering. So if I refresh this screen, that actually was an HTTP GET. It went and got some JSON and then templated it out on the screen. If I go to this form, I can add a new contact. Let's add myself. So that was an HTTP post. I added a new contact, and it just did an AJAX call back to the Web API. And I can do delete. I can remove a contact, and that did an HTTP delete call back to the backend Web API. And I have a second client for this too. This is a Windows 8 Metro application, and it's pulling from the same data. Just to show you that it actually is pulling from the same data, let me go back here, add myself back, and I'll just refresh the screen. You'll see Dan now shows up on the screen. If I delete, I didn't actually bother to implement delete and post on the Windows 8 client. At some point we'll get there. So I remove this and go back. We'll just refresh so that it pulls down the data again. You see Dan's now gone. So these are two apps that are exposing similar functionality, but they're using the same back-end Web API to achieve it. Let me show you some of the client-side code. This is the Razor view for the MVC application. Like I said, it's using Knockout to bind the data to the UI. But you can see here to actually get the data, there's this jQuery get JSON call. It's just doing an AJAX get to pull down some JSON from the Web API. To post a new contact, you'll see here's the AJAX post request. It's just posting the new contact to the Web API. And then delete. Again, just an AJAX call. If we look at the Metro app only does get. Sorry, at some point I'll get to post and delete. But here's the actual get call. It's just using the new HTTP client in .NET 4.5 to issue a get request to the Web API, pull down the data, and then bind it to the XAML. To prove to you that this is actually the case, that this is really happening, what I'm going to do is going to fire up the Internet Explorer built-in debugger, and I'm going to start network capture. And I'm going to F5 to refresh the page. And you'll see a whole bunch of GET requests to pull down the JavaScript and the HTML and the CSS. But at the bottom here, you will see that GET request to the Web API. That's a call to, I know it's small, I apologize. It says API/contacts, GET. It was a 200 OK. If I look at the response, you'll see there's the data. There's the actual JSON payload that came back from the Web API. Now let's do post again. So I'm going to post Dan. Save, and you'll see a new request showed up in the debugger, and it is in fact an HTTP post. Now the post request body in this case is form URL encoded data. HTTP is all about formats. There are lots of different media types out there. One of the things you deal with when you're building web APIs is how can you support the formats that matter most to your particular application. When you're dealing with HTML forms, form URL encoded data is pretty convenient. The response comes back as JSON. Because that's easy for clients, like browser clients, to deal with. And then lastly, if I do a delete, remove, you'll see a delete request actually shows up here. Nothing surprising there. All right? And this thing also supports, and speaking of formats, this thing supports retrieving images from the Web API. So we're not just talking about text-based data. The data could be binary, it could be PDFs, it could be whatever. All right, cool. So that's an example Web API application. And what we're going to do today is we're going to talk about how you can build such a thing. So we want to help you do that. We wanted to create a framework that would make it easy to build web APIs. And when we set out to do this, these were, I think, were our goals. First and foremost, we wanted to give you a great first-class modern HTTP programming model. And this should allow you to do anything you want with HTTP. You should be able to access headers. You should be able to set status codes. You should be able to deal with caching. You should be able to deal with anything in the HTTP payload that is interesting to touch. Second, we wanted to make it really easy for you to implement your HTTP resources, to actually implement the uniform interface of HTTP, get, post, put, delete, patch, whatever. And then to take those HTTP resources, those endpoints, and actually give them their URIs, give them their identities, and be able to give them nice URIs that make sense. HTTP, like I said, is all about formats. We wanted to have a model where it's very easy to implement support for a variety of media types, and also be able to leverage the built-in mechanism in HTTP for doing content negotiation. Content negotiation is a process where a client can say to a server, gee, I really like the contacts. And when you give them to me, I prefer them as JSON. If you have them as XML, that's OK, or anything else you got. And then the server can look at the formats that it supports. It can look at the client request and decide how to format out the response to the client through this content negotiation process. We wanted to make sure we supported that, that mechanism in a first-class way. With HTTP, there are lots of cross-cutting concerns, dealing with caching, dealing with wiring up links. We wanted to make sure that there was a way for you to pull out that logic into common components and then apply them in a cross-cutting way. And lastly, we're trying to simplify here. It's just HTTP. We wanted the whole framework to feel lightweight. We wanted to think about testability from the start, and scale, of course. We wanted to be able to scale really well. Now, Microsoft, honestly has been working on Web API frameworks for a little while now. This isn't the first time that we've set out to build something. On the ASP.NET side of the house, we've had MVC. And since V1 of MVC, you could build simple web APIs. You could return a JSON result. If you wanted to just create a simple web API that all it did was return some JSON, that was really easy to do with MVC, and that was great. Beyond that, it was more of an exercise to the user, but for simple cases, it was nice. On the WCF side of the house, starting in .NET 3.5, we started building the WCF Web HTTP programming model, where you could take your WCF services and you could add URI templates to them. You could configure a binding that would let you not do SOAP, but just do raw HTTP. There were a couple of out-of-band efforts also on the WCF side. There was the REST starter kit. Maybe some of you remember that. That pioneered a lot of the ideas around how we might build a Web API framework. I think the HTTP client that I showed you earlier, the first edition of that, I think, came from the REST starter kit. A lot of the ideas from the REST starter kit made their way back into .NET 4 in the updated WCF Web HTTP support in .NET 4. And then after that, we went out of band again with WCF Web API, which pushed ideas even further, the idea of formatters and content negotiation, and they had an operation handler concept for doing cross-cutting concerns. It was a fairly powerful framework. But with WCF, you tended to get, because WCF is intended to do so many things, you tended to get more complexity. And also, it still felt like you were swimming upstream a little bit. WCF at its core was really intended to be a SOAP stack. Like if you look at the message abstraction in WCF, it has an XML info set. And, it kind of looks like a SOAP message. And getting raw HTTP through it is a bit of a trick. So what happened was, well, honestly, there was a team restructure. The ASP.NET team and the WCF team, we're all basically one happy team now. And we looked at this situation. We were getting questions from all sorts of customers. What should I use? Should I use MVC or should I use WCF? And we would, go into our song and dance about the benefits of each. And we said, this is silly. Let's just build one thing that takes the best of both worlds and gives you a single experience for building web APIs. And that's where ASP.NET Web API came from. Now the MVC support is still there. The WCF support is still there. You can still use it. It's still supported. There are a lot of people using WCF REST, for example, internally at Microsoft. I'm sure many of you are using it, and that's fine. And in fact, if you have a lot of WCF infrastructure, adding an HTTP endpoint to your service may be the right way to go. That may be very simple. But we found in general, based off of feedback from people who have been doing that it works, but we'd like something better, something that really will treat HTTP as a first-class citizen. And that's what ASP.NET Web API is about. If you're trying to build web APIs that are trying to do reach, use HTTP as an application-level protocol, you should use ASP.NET Web API for pretty much most of your web API scenarios. So here are the features that we took. From the MVC side, we kept ASP.NET routing as the way that you identify your HTTP resources. We kept model binding as the way that you pull data out of the request, and we support validating that data. We kept MVC filters as the mechanism for doing cross-cutting concerns. You can do link generation. We've been designing for testability from the start. You can do IOC integration really easily. We actually have been meeting with a bunch of the IOC authors and trying to make sure that our abstractions are really good there. And you get the nice tooling, the scaffolding, the templates. From the WCF Web API side, we kept the new modern HTTP programming model. A strongly typed HTTP request message and a strongly typed HTTP response message. And these are first-class citizens in the framework. And they're used symmetrically on both the client and the server. The new HTTP client in .NET 4.5 uses these same abstractions. And we've actually taken that HTTP client and we've backported it to .NET 4. So you can, the whole framework is available on .NET 4, and you can use the client and server on .NET 4. The entire stack is, we want it to be scalable, so we made it asynchronous, and it's using the new task-based async model. We wanted to support formatting, so we kept the formatting abstraction. We kept the support for full content negotiation. We support the OData query syntax, a limited form currently, but we're working on more. Currently, we support top, skip, order by, and filter. We've just, in the release candidate, we released the ability for you to get runtime description information about your web APIs, so you can do things like build custom help pages, build test clients. We support self-hosting web APIs. You don't have to host them in ASP.NET. And we get great tracing infrastructure, which is also new in RC. And I'm going to try and talk through as many of these features as I can. We'll see how far we get. Now, where do you get the bits? Because you can get them now. You can go to the ASP.NET website, www.asp.net/webapi, and you want to install ASP.NET MVC4, the release candidate. Web API ships with MVC4. And on this site, you can also find all our documentation, our samples, videos. If you have any questions about using the framework that I don't get to here, you can post to the forums on the ASP.NET site. We are, as a team, monitoring those, and we can help you out. The whole framework also is open source. The code is available on our Coplex site. It's available under an Apache v2 license. We also accept third-party contributions. This was a fairly recent announcement. And actually, in this release, we have accepted third-party contributions. It is real. If there's anyone in this audience that contributed, thank you. We appreciate your bug fixes, your new features. Someone checked into MVC, actually, the support for the HTTP patch options and head attributes. So that was cool. We still are accepting, we can still accept contributions, so if you're interested, start a discussion on the forums on the Coplex site. I'm happy to talk to you about how you can help us out there. We are locking down the release right now, so you may not be able to get into this release, but of course there's always the future. The other nice thing about us being open source is that you get unprecedented transparency into where we are at with the project. When our devs check in, they are using the Git repository that's set up on the Coplex site. So when they check in, you see it. Like it's this there. And in fact, we have nightly public signed builds from the Coplex site. I mean, these things aren't supported, and I wouldn't recommend doing any serious development on them. But as a way to get a view into what's coming down the pipe, it's really nice. You can look now and see where we're at, post the release candidate. You may notice that the check-ins have sort of slowed down. There's not as many of them, and that's because we are locking down and getting ready to release. So pretty cool. All right, let's build one. Let's build a web API. So let me switch back to my machine. I'm going to open up a new instance of Visual Studio 2012 RC. This may take a few moments. There it goes. OK, file, new project. ASP.NET MVC4 is included with Visual Studio 2012 RC, and that includes the Web API stuff. I'm going to create a new Web API by creating a new MVC4 web application. I'm going to do it that way because there's some nice tooling that's wired up there. You don't have to do it this way, though. If you want to use Web API from a web forms application or from a website, that's perfectly fine. There's an item template you can use to add it. Pretty simple. But I'm going to do it this way just because this is a nice way to get started. So OK, let's do my first. I think this is still my first one on this one, Web API. Let's see. Great. OK, this will bring up the MVC4 new project dialog. And you'll see I have a Web API project template set up for me here. That's awesome. I'm going to select that. I have the option here of creating a unit test project, just like you could with MVC. And this will create another project in the solution that'll already have all the assemblies wired up, all the NuGet packages. So it's really easy for me to get going fast writing unit tests for my web APIs. I'm not going to do that right now just because I want to keep it simple. Before I click OK here, for those of you who are using the beta, you may notice an omission here that there used to also be a single-page application template. And that was a framework that was built on top of Web API for doing really rich, interactive client-side browser apps. It's not in the RC. It's not going to ship in the final version. It needed some more bake time. We're still working on it. The code is in the Coplex site, so you can monitor it there. And we do plan to ship it. We just needed some more time to get it ready. But it's coming. It just won't be in this release, but it will come as soon as we can get it done. All right, I'm going to click OK here. And this is going to create for me a new Web API. Right now, what it's doing is it's installing into my project template a whole bunch of NuGet packages, including the Web API NuGet packages. Web API is available on NuGet. That's another way you can get the binaries. You can just create a console app, right-click, use the do you guys know this? You guys know NuGet? You should know NuGet if you don't. You right-click, manage NuGet packages. This will bring up the NuGet package manager, and you can search on here. Actually, I'm not connected to the network, so I can't search right now. But this would normally pull down the public NuGet feed. You can select the Web API package, and it will just pull it down and plop the binaries into your project. So that's pretty nice. We're available on NuGet. All right, what did this give me? This gave me an API controller. A lot of the concepts that you'll see in Web API will look very similar and analogous to concepts you may be already familiar with from MVC. They're not generally exactly the same concepts because Web APIs are fundamentally different. But we wanted to enable you to reuse the knowledge that you already had. So when you're creating a Web API, you're going to create a Web API controller. Just like if you're creating an MVC app, you would create an MVC controller. Now, what's different about this controller? Well, you'll notice if you look at my actions, let me collapse the definition so you can see more of the actions are. The actions are actually the HTTP methods, right? They're get, post, put, delete. And this is different than MVC. Like, how does MVC work? If I pull up the MVC default route, here's the MVC default route, right? If you use MVC, you're probably really familiar with this. When a request comes into MVC, MVC will take the URI, and it will parse the first 3 path segments, and it'll say, well, the first path segment, that's the controller. I'm going to go find a controller with that name. The second path segment, that's the action that I want to invoke on that controller. And it will literally go look for a method with that name and call it. And then there's an optional ID parameter at the end. With Web API, look at this is the Web API route. We use routing, like I said. And it's a little different. We prefix with API just to make sure, keep the Web API routes a little bit separate from the MVC ones. We use the controller variable, so we'll go find a Web API controller based off of that controller variable. But there's no action variable. That's because my actions with the Web API are the HTTP methods. When you get a GET request, we're going to go call your GET action. When we get a POST request, we're going to go call your POST action. And we have a little simple convention that we use for defining those actions. You just prefix your method name with the HTTP method that you want to handle. So here I'm just using the HTTP method names, but these could have been like, get values. That would have been fine. That has the same semantics. If I don't like that convention, that's fine too. Like, let's say I wanted to call this create instead of post. That's cool. Just make sure you attribute your action with the HTTP post, put, delete set of attributes so we know which method you want that action to handle. If you don't use the convention and you don't put on an attribute, then we'll just assume it's post if it's a public method. All right? Cool. I like the convention, so I'm going to put it back. All right, let's run this thing, see what it does. This is going to pop up the browser. And the project template includes a little MVC controller with a view to give you some text about how to get started with Web API. Go to the Web API side, you find the samples, find the documentation, et cetera. But I want to actually call the Web API. So how do I do that? I'm going to do it using the browser. I'm going to issue a GET request. What URI do I type here? Well, you remember the route, right? Go back to the route. It's going to be API/controller name. Well, my controller name is values controller, so it'll be API/values, and then there's an optional ID. Okay, let's do it. API values get. Now, this is a web API. It's returning data. It's not returning HTML that the browser can then render. So you notice there's this little gold bar that popped up at the bottom. The IE is telling me, hey, I got some JSON. What do you want me to do with this? I'm going to ask it to open it in Notepad. And there you see I got some JSON back from my web API. Similarly, I can do API values and pass in an individual value, and that'll give me a single value back. Okay? So we just invoked our our first web API. Now this is a very simple, not particularly useful web API, right? Like it's just returning static data. You know, these are just strings that are hard coded in. Normally you're going to want to return some interesting data, like wire it up to some backend store. The web API instances are created once per request. So you're not going to be able to keep the state in the controller instance itself. So you'll have like some wire up code to any framework code first or something like that. And I'll show you how to do that in a minute. But still, this is still pretty powerful. Actually, I wanted to show you one more thing. This web API can do some interesting stuff. I'm going to pop open Fiddler here. And Fiddler is a great tool if you haven't used this before. If you're building HTTP services, it allows you to create new requests, see what's going on the wire. And I'm going to do another get. But this time, I'm going to use HTTP to ask that little values controller. Actually, let me do the vanilla get first, make sure that's working. OK, 200 OK. I got my JSON back, just like before. Value 1, value 2. So there's the JSON. But now I want to ask it, please don't give me JSON. I would like XML. I accept XML is the way you say that in HTTP lingo. I'm going to issue the request again. And notice now the response body that I got back is actually XML. Because the web API out of the box is just going to support full content negotiation. See, I've got pointy angle brackets instead of curlies. OK? So it can do connig. All right, great. So if you want to implement a web API, what do you got to do? Well, first you derive from API controller, and that's your hook into the dispatcher. And there's all sorts of useful properties, just like in MVC and the MVC controller, that hang off that type. And then you implement your actions on the controller. And your actions are going to be the HTTP methods, get, post, put, delete. Use the convention, prefix the method with the HTTP method that you want to handle, or you can use the HTTP get, post, put, delete, patch set of attributes to specify the specific method that you want to handle. When you're defining the URI space for your web API, giving your HTTP endpoints identities, you're going to use routing. And we provide a default route for you. It'll be API/controller/ID. And the controller is how we're going to find your web API controller. We'll go look for a controller with that name. And then the actions will get selected based off of the HTTP methods. And you can use default values in your routes. You can use routing constraints. All that stuff works. You can also configure additional routes. When you configure additional routes, you should use the map HTTP route extension method. And when you do so, you do have the option of actually putting in an action variable. The default route doesn't have one, but you can put one in, and we will honor it. That's useful if you do want to do more RPC-like patterns with Web API. And it'll work just like MVC does. We'll go call a method on your controller. But we lean more towards the resource-centric approach with Web API, where you basically have a single controller per resource, and that controller implements the interface for that resource. We favor that more factored approach. You can still have a single, big controller with lots of methods on it, like calculator with add, subtract, multiply, divide, and you can do it that way. Just add a route that has an action variable in it. That will work too. This is our default route, API controller ID. OK, so now you've got some actions. The request comes in. Data from your request is going to get bound to your action parameters. When we call your method, we'll pull data out of the request and give it to you as strongly typed parameters. How does that work? Well, it works using a form of model binding. And it's similar to the MVC model binding, but a little bit different and specific to Web API, mostly because we handle the body of the request in a different way. The way you should think about how the parameters will get bound is that if you have a simple type parameter, like a string or an int or a double, something that can be converted to and from a string, we will take that data from the URI. Like it'll be a query string parameter or a route data or maybe form data that's been put into the URI. Simple types, we assume come from the URI. And we'll just match them up based off of name. If it's a complex type, we're going to assume that comes from the body. And the way we'll process the body is we will use your configured set of formatters. The way you deal with formats in Web API is using this media type formatter abstraction. You basically have one of those for each media type that you want to handle. One for JSON, one for XML, one for PDFs, PNGs, whatever. And then we will look at those formatters, and we'll look at the content type of the request and deserialize the data from the request using the appropriate formatter. Okay? Out of the box, we provide a JSON, XML, and form URL encoded formatter for you that you can just use. Now, if you want to change how the parameters get bound, like you have a string, but you want it to come from the body, not from the URI, then you just need to attribute the parameter with from body. If you have a complex type, like a location that has an X and a Y, but you want it to come from the URI, you don't want it to come from the body, like you have an X and Y query string parameter. You can do that too, just attribute the location type with from URI. You can also use full MVC style model binding, and you do that by attributing the parameter with a model binder attribute. When the data comes in, just like MVC does, we will run full validation on your data. It's run on every request. The errors are accumulated in the model state on the API controller. So when you're writing your actions, you generally want to check, model state is valid to see if the data is actually valid. And the way you can specify what validation rules you want run on your model types, you can use the data annotations, required and so forth through the set of attributes, or you can wire up your own custom model validator. So that's inbound. Now you've executed your action. Now you want to return the data as a response back to the user. How does that happen? Well, the response is, the format is determined using HTTP content negotiation. And we will look at the accept header sent by the client and pick the appropriate format again that you've configured, but this time using content negotiation algorithm, not looking at some content type header. And the server will select a formatter based off of these three things, based off of the client request, the return type of your action, because formatters can say, I only support formatting these types, and also the set of formatters that you have configured. And for formatting responses, we just support XML and JSON. It doesn't really make sense to serialize out form URL encoded data. One thing I will say here is that for JSON, which is our default formatter, like if I say nothing, if the client just says, give me the resource, you're going to get JSON. And the default JSON formatter is going to use JSON.NET, actually, as the serializer. We build against JSON.NET in ASP NET Web API. It's a very popular third-party JSON serialization stack, very flexible, has a lot of features. You can really get great control over the format. It has support for dynamic parsing of JSON. We just include it. You can use it now. You don't have to go download it yourself. It's included with ASP NET Web API. We decided to do that because we needed a JSON serialization stack that was really moving with the pace of the web. And honestly, the framework ones were a little bit behind. We still support the framework ones. Like if you want to use the data contract JSON serializer, you can just flip a switch on the formatter and we'll use that one instead. Now, how does content negotiation happen? This is the actual manual steps. You don't have to write this code. You can write this code, but you don't have to. But it's useful to know what's actually going on. When content negotiation runs, Web API will go to your configuration and ask for a content negotiator service. And we provide one for you. But if you want to implement your own, feel free. We'll then call negotiate on that service, and we'll pass in the request and the type of that you're trying to return and the set of formatters that have been configured. And it'll pop out the formatter that it's selected and say, well, this is the one that you should use. You should then create a response message, and you set up an object content for that response message. And you put the object you want formatted in the object content, and you give it the formatter you want it to use to format, and you send it on its way, and when it gets written out, it will use that formatter. Now, we package all this up for you in a simple extension method, the create response. So you can take your request, call create response of T, and that will run full content negotiation for you and just give you the response message all set up. This is a little different than the beta bits. If you've been using Web API on the beta, there were these generic versions of HTTP response message that you could use. I had a lot of issues with those. They were specifying a contract that we really couldn't enforce, that the content of that response was actually an object content, when in reality you could swap it out. It meant you had to do if checks all over your code to see, am I dealing with a generic HTTP response message or just a normal HTTP response message? We decided to simplify and go with, you just return an HTTP response message and use this code to actually set it up if you want to run full content negotiation. All right, so that's how you would write your actions. Now, good news is that you don't have to start from scratch doing that work. What I'm going to do now is go to back to my, my first Web API project, and I'm going to create a more interesting Web API this time, something that actually has some back-end data. I'm going to create a model. Let's just add a new class. Let's call it contact. Okay, this will be my model type. Let's add a couple properties to this thing. It's just a normal POCO, plain old C# type. I'm going to give it a contact ID. I'm going to need that for any framework code first. And then I'm going to give it some data. Let's give it a name, the name of the person. Let's also wire up some validation logic. I'm going to put a required attribute on the name. OK? Let's build that. So this is a contact. It has a name. It has an ID. And the name's required. Now I'm going to create a new controller. I want to create a Web API that manages a list of contacts, kind of like the way my contact manager app does it. So the way I can do that is I can right-click on, on any folder really, but I generally put them in the controllers folder, and I can say add controller. This is tooling that shows up in the MVC project templates. You won't see this, I think, if you're in the a vanilla ASP.NET project. But if you're doing MVC, you get this nice tooling, which is pretty cool. So add controller. Okay, I'm going to call this contacts controller. And then I have a bunch of templates that I can pick from here that MVC uses to scaffold out a controller for you. Normally, you would do this with MVC controllers, and it'll create controllers and views. I want to create a Web API controller. And you'll see there's an option here to create an API controller with read-write actions using Entity Framework. Sounds like what I want. So I'm going to pick that one. And then for my model type, I'm going to use my contact type. There it is. Just going to pick it from the dropdown. And then I want a new data context. I don't have one already. And let's call that contacts context. All right, ready to go. So this is going to scaffold out for me a full contacts controller that is using a backend database. We'll just give it a second. There it is. All right, cool. So let me, again, collapse the definitions so you can see what this thing did. Again, I'm just getting my HTTP actions. I can get the full collection of contacts. I can get individual contacts. I could put would be update a contact and create a new contact and delete. And then dispose will dispose the DB contacts. Let's look at the implementation of some of these things. So getting the contacts, that looks pretty simple. It's just going to return the full set. Get with an ID is a little bit more interesting. That's going to do a find, right? And the contact may not actually be there. Now, in HTTP sense, what you would normally want to do here is you would say, not found, right? 404, right? Is that 404? Yeah, not found. So now, the way I can do that pretty simply is I'm going to use the scaffolding code uses this HTTP response exception type. This is just a really easy way that if you're in an action and you want to just shortcut and say, something's gone wrong, return an error response, you can throw one of these, provide us the response message. Here I'm using that create response extension method, and we'll just ship that error response message back immediately. Okay? And I don't have to change my action signature. So throw new HTTP response exception, and this just takes in the response message that I want it to use. And here I'm creating a response message that does a 404 not found. All right, that's cool. Let's look at post. So post is supposed to create a new resource, create a new contact in the collection. So it takes in the contact, and that came in through model binding. In the contact manager app, you saw it came in as form URL encoded data, name value pairs, and we were able to bind that to a contact instance. Here you see the validation check. So I could check the model state to see if that model instance is actually valid. There's some DB context code here to actually add the contact to the database. And then when you're, man, I wish I had more. I wish I had a bigger screen. Let's see if we can make this a little bit easier to read. All right, cool. So when you're in HTTP, when you're creating a new resource, you generally want to do two things. You want to say, first of all, 201, I created a new resource. And then second, you're supposed to put in a header, a location header, that tells the client, and the new resource I created is over there. Okay, well, with Web API, it's really easy to do that. So I create my response message. I'm going to notice I'm returning HTTP response message from this action. I can just use HTTP response message and request message as first-class citizens. And the way I create the response is I say, oh, the status code should be 201, and here's the contact that I want you to return back to the user. And I can set the location header. Notice location header is a strongly typed header. All the headers are nicely strongly typed. This is a very nice, new, modern HTTP programming model. To generate that header, I need to produce a URI that says, and it's over there. We provide link generation help. This URL property is on the API controller, and it's of type URL helper. And what that does is I tell it which route I want it to use. This is just the default Web API route. Here. Comes from here. So that's the name of the route that I want it to use. And then I just tell it the data that I want it to use to sort of fill in the holes in the route. So use the API/controller/ID route, and for the ID, use this contact ID is what this is saying. And it'll produce a URI for me. So that's pretty nice. The host will come from the request message automatically. We'll just take care of that for you. And then I just return the response. Okay, so here you're seeing model binding, you're seeing validation, you're seeing content negotiation happening, you're seeing link generation, and the first-class HTTP programming model being sent back to the client. Now, this is code that scaffolded code is not code that you have to use as is. The idea is you're supposed to be able to go in, you can modify it, you can change it. Actually, before we get there, let's go ahead and run it, see what this thing looks like. Okay, so this is a contacts controller, so I need to send a request to API/contacts. Little delay while it sets up the database, probably. All right, open. Well, there's no contacts, so I got an empty array. Okay. Well, I want to create some contacts. Well, let's use Fiddler to do that. So compose. I'm going to do a post. And I need the URI. Let's get the URI off here. I'm going to post to API/contacts. I'm going to post to that collection resource. Let's use JSON as my content type. Application/JSON. All right. And then it has a name, right? And let's post myself. Okay. Let's try that. Post. Okay. Notice I got a 201 back. So there's the created status code. If I look at the headers, down here you'll see the location header, and it tells me exactly where that new contact is. Should we go see if it's there? So API/contact/1 is what it said, right? Open. Yeah, there's my contact, right where it said it would be. If I request the complete collection, I now get an array with just one contact in it. Let me show you validation. If I try and post a contact now, but let's say I mistyped the name, foo here instead of name. Let's execute that. Let me put a breakpoint in my post action. Execute. Okay, so we're now in the post action. Let's see what's the model state. The model state now says that is valid is false. I don't know if you can read that, but it does say false. That's because we looked at your attributes on your contact model, and you said, well, the name's required, and there's no name in that JSON payload, so not valid. And if I actually drill down into the model state, what is it? Values, somewhere in here, errors. You can see here's the error message, required property name not found in JSON, line 1, position 17. Okay? So you get full validation also on the data coming into your web APIs. Cool new feature coming post RC, post the release candidate, is we're going to give you a HTTP errors type that can package up the model state and conveniently serialize it back to the client as a JSON payload, so you can actually give the client that error information really easily. All right. Now, like I said, the scaffolding code is not something. It's not fixed. You should feel free to modify it. And that's actually what I did with Contact Manager. When I implemented my contacts controller in Contact Manager, I started with that scaffolded code. I then just wrapped it in a repository pattern, this iContact repository. And then that repository is getting injected into my contacts controller using an IOC container, using Ninject. Here, I'll show you the config for that real fast. So here's my configuration for that web API. We'll talk about all this other stuff in a second. But down here, for those of you who are IOC fans, you can see I'm wiring up an inject kernel to web API. And we'll use that when we new up your controller instances. We'll look to see if you've registered one of these dependency resolver things. And if you have one for your favorite IOC container, we'll call into it and say, hey, do you have an iContact repository for me? And it will say, why, yes, I've bound an iContact repository to the specific one from Entity Framework. Let me just give it to you when I new up your controller. So we have good integration with IOC. OK. Let's go back to this. All right. What about cross-cutting concerns? Like take that validation code that I had. If model state is valid, then do my action. What if why do I have to write that in every single action? Why can't I just pull that out and do it in a cross-cutting way? You can. You can do that using filters. This is very similar to the MVC notion of filters, although they are web API specific. There are 3 kinds of filters in web API. There are action filters. And action filters are pieces of code that basically run right before your action is invoked and right after it's being done invoked. And so you could write an action filter, for example, that before the action is invoked, checks the model state and says, are you valid? And if it's not, it could just fail right away, and then you don't even have to deal with that code in your actions. There are also authorization filters. Authorization filters are very similar to action filters. They just run earlier. They run before model binding has occurred. So you can put your authorization logic there and save yourself some CPU cycles if you find out, actually this person's not authorized at all, so I'm not even going to bother to pull data out of the request. Exception filters are kind of like a finally clause in the stack. At the very end of the pipeline, if there's an exception that's occurred and no one's handled it, you can plug in an exception filter as a way to say, if an exception has occurred, no one's handled it, return this HTTP response message as the error. And filters, just like in MVC, you can configure them globally for the entire app. You can configure them on your controllers, or you can configure them per action. Here's a picture of what the Web API dispatcher looks like. And I think we've talked through every piece on this diagram now. The request comes in. We run it through routing. And we pull out the route data. We use the route data to select a controller. We instantiate your controller, and we select an action on it. And then we run the authorization filters to see if the request is authorized. The way security works in Web API is that, in general, we honor the thread.current principle. So as long as the thread.current principle is correctly set up, then we will use that. So in your authorization filter, you can look at thread.current principle. We then model bind the data to your action parameters. We call your action filters, invoke the action, and then unravel. We'll call the action filters again to let you know that the action's been invoked. We'll call your authorization filters again. Exception filters are at the very end. Gives you a last chance to say, do you just want the server here to fail, or do you return a 500, or do you want to actually return a different kind of HTTP response message? And at the very end, we format the response to the client. One of the filters that we provide out of the box is support for OData queries. The OData spec defines query semantics that you can include in your URI query parameters for doing things like just give me the first 3, give me the first 3 after you've skipped a bunch, order by this particular property name, filter using this filter expression. And we support OData query semantics out of the box in Web API. And let me show that to you now. OK, so to do that, I'm going to use the contact manager sample. This is not the contact manager sample. Let me close this. OK, here's my contact manager sample. So here's my GET request. Looks similar to the one that I scaffolded out, except there's 2 changes here. I'm returning an iQueryable now instead of just an iNumerable. And then I applied the queryable attribute. And that queryable attribute is an action filter. After the action is called, we'll parse the query string, create an expression out of it, and attach it to the queryable so that when we pull from that queryable, the query will actually run. All right, so let's go to Contact Manager. Let's do this in, yeah, we can do it here. OK, so API/contacts. that returned me some JSON. There's all my contacts. Okay? But I don't want all of them. I just want dog, question mark dollar, top equals, let's say the first two. I just want the first two. So let's see what that gave me. Okay, now I've only got 2 contacts that came back. All right, that was cool. But now I want, order by, you can tell I've been practicing this. Order by name. So I want the first 2, but order by name. So that should be what? Like Dan first, and then Glenn, I think. Is that right? So Dan and Glenn. So that was sorted for me. All right, cool. Now I want order by name, but I want you to skip. Skip 2. So that should be what? It should be Howard and then Jeff. Yeah, so Howard and Jeff is now what I get. Okay? You'll notice that the query support is independent of the format. Like I was doing OData queries over just raw JSON. We've decoupled these 2 concepts. We don't currently actually have an OData formatter in Web API. We are working on one. And we are also working on broader query semantic support for Web API. It'll probably ship out of band from Web API. Time frame still working on that. I can't commit to anything yet, but we are working on it. But the cool thing to notice here is that you can do queries independent of whatever format you're operating on. So that was a nice cross-cutting concern. That meant I didn't have to write a bunch of actions for every single query that I wanted to execute. All right, now what's happening below the dispatcher, though? Like, where does that request and response coming from? How is HTTP handled at the lowest layers of Web API? At the bottom of Web API is really just a message handler chain. We have an HTTP pipeline, and the component in the HTTP pipeline is a message handler. You can see the message handler abstraction at the bottom there. It's really simple. It's a thing that has a send on it, and you give it the HTTP request message, and then it's going to return you an HTTP response message. And it's async, so it returns task of HTTP response message. You can cancel in these things. You can return right away. Pretty flexible and scalable HTTP pipeline model. On the client, you use the new, if you're writing in .NET, you'll use the new HTTP client that ships in .NET 4.5. And like I said earlier, we backported it to .NET 4, so you can use it on .NET 4 as well. The HTTP client has a message handler associated with it. By default, that message handler is an HTTP client handler, that big orangish box. And that's just a message handler. You give it an HTTP request message. And what it will do with it is it will send that request on the wire using HTTP web request, essentially. And you can plug in other message handlers in on the client. You can swap out a different message handler instead of HTTP client handler. So the request then goes on the wire using HTTP web requests. And then there's some hosting layer for your web API. Usually that'll be ASP.NET if you're hosting in IIS, but it doesn't have to be. We'll talk about some of the other hosting options in a minute. The host just needs to be able to take the request that came off the wire and reconstruct the HTTP request message instance. And then it hands it to our Web API HTTP server. There's an actual type, HTTP server. That's the core Web API hosting piece. It is itself just a message handler. You just call send on it, and you give it the request message, and it hands it up its own message handler chain. The last message handler in that chain is our dispatcher, and that's the picture you saw before. That dispatcher is just a message handler, but it will go find a controller, select an action, execute the action, and run all the action filters, etc. Now, the cool thing about this is you'll notice that the HTTP programming model is completely symmetric. I think for the first time at Microsoft, you now have the same HTTP programming model being used on the client and the server. You'll notice also that the HTTP server is itself a message handler. If you want to, you can just hand that to your HTTP client and run the full pipeline all in memory. And that's a pretty convenient way to do end-to-end testing. All right, cool. Let's see an example of a message handler. Now, with Contact Manager, one of the things I've done is I've wired up a pretty common convention where you can put these little file extensions on the URI. Like here I wrote .xml. And what this means is, from the browser, I can't really change the accept header. But let me use a URI convention where I'm basically saying I'd like this back as XML. Okay, so that works. So somehow the server interpreted that .xml to mean give me XML. How did I do that? Let's go look at the code. I did it with a message handler. One thing I'll mention about message handlers, a lot of people ask, when should I use a message handler? When should I use an action filter? The difference between the two is that message handlers will run for every single request. Action filters run later in the pipeline. Like they can look at the model-bound data, the controller context, and they can be more scoped. You can run them per controller or per action. That's the way to think about it. Okay, here's my message handler. Here's the send a seek method, right? It takes a request message, it returns a task of HTTP response message. Now, what does this guy do? Well, it looks at the URI for the request, and it looks for that extension in the URI. And then I just have a little static table where I map extensions to different media types. And then what it's going to do is if that extension is found, it's going to add it to the accept headers of the request. So I'm actually going to stuff an accept header into the request really early on in the pipeline, well before content negotiation has even run. And then that request is just going to flow on up. And when it gets to the content negotiation logic further in the HP dispatcher, it'll look and say, oh, well, here's an accept header. I'll just use that, and the normal logic just applies. Okay? So that's how that works. That's just a message handler. I've also wired up a couple of custom formatters in this sample. HP is all about formats. The images that you saw were actually being produced by this contact PNG formatter. This is in this case, it's a buffered media type formatter, but it's that media type formatter abstraction. And the way you implement a custom formatter is you just need to be able to take an object and serialize it to a stream. And you need to be able to take data from a stream and produce an object. That's all it is. So write to stream is the take an object, serialize it to a stream part. And you can only, if you want to, you can implement just half of the abstraction. In this case, I only wanted to be able to produce images. I don't accept images, so I only wrote the write to side. But this is really simple. For the object, I check if it's a contact, and then I just go grab some file off of disk, and then I just write that file out to the stream. Very simple. You can also say what types you support. Here I say I only support writing types of type contact. I have another formatter here. This is a vCard formatter. This is like an electronic business card format. Similar concept. I implement write to stream. This can take either a enumeration of contacts or just a single one, and then it just writes out to the stream the text for vCard. So let me show you what that looks like. And I'm going to use the file extension convention to request this data. Okay, you already saw XML. That was cool. Let me do PNG. So. Great. Come on, man. Hold on a second. File system's not high. Can I request the images? Yes, I can request the images. So let me do it this way. Well, you can see the URI there is right. Let me see if I can if contact to PNG. Do it. Let me. Last time this happened, I have some sort of condition here. I set a breakpoint here, and everything started magically working. All right, so I'm in my formatter. I go get the thing. Let's let this run. No? I'm in my formatter, right? Some exception must be happening. I'll try that one more time, see if I can get this to work. I mean, it's working. I just don't know why it's not working this with an individual request. Yeah, I don't know what's going on there. Just going to rerun it once. No, it's not cached. I don't. Well, actually, I can check. Contacts to PNG. Let's do F12. Let's see what. Sorry, what was that? Yeah, it does eventually. So let's see. All right, that's my request. I don't know why. So I got some sort of bug in my code, some sort of race condition when I pull from the file system. Well, there it's working. So you can see the response body is an actual image, and that was rendered by the formatter. Whew, man. OK, let me. I wired up the vcard formatter to the VCF extension. OK, if I look at what that looks like, I'm going to open it. VCF is actually a format that's supported by lots of contact management tools like Outlook, so it actually pops up in Outlook when it renders that that file. If I look at the actual text that came back, this is what a vcard looks like, and that was produced by the vcard formatter. Cool. Whew. So the question was, are the JSON and XML formatters available by default? Absolutely. On inbound, you get JSON, XML, and form URL encoded. On outbound, for content negotiated, you get JSON and XML, because it doesn't make sense to write out form URL encoded data usually. It's usually just something you're reading in.
Are there any issues using Web API with the Unity block?
Unity, the IOC container, is that?
Unity application block, Unity IOC container.
There shouldn't be. If there are, let us know. We worked really hard.
I had to install a package to get it working.
What's that?
I had to install a package to get it working. Web API.unity or something.
Oh, OK. That's not a package from us, but if someone put up a Unity package for Web API, that's great. Yeah, that's pretty cool. OK. So let me show you I just want to make sure you see the config. Got a couple more demos I want to get to, so I'm going to hold on for your questions. We'll leave some more time for questions. This is the config where you can actually see I wire up the formatters. So yeah, the XML and JSON ones, they're just there. I do some config on them so that they pretty print, but they're just already there. The vcard and PNG formatter, I just add to the formatters collection. This HP configuration instance is where you do all of your config for Web API. It's all in code. It's imperative. It's very simple and centralized. Here's my message handler. I just add my URI format extension message handler to the config. You saw the IOC container wire up before, and then here are my routes. And I add a couple of routes so that I can do that extension mapping trick, so that I support the dot extension URIs. OK? Cool. OK. Great. So that's a pretty functional Web API at this point. It's got a variety of formats. It's got backed by Entity Framework, database. It's doing content negotiation. That's all great. Often when you build a Web API for third-party consumption, there's no WSDL for Web APIs, right? So typically you need some sort of doc or something that describes the Web API and lets people know how to use it. Frequently, the metadata for Web APIs are, here's an example request payload that you can send me, or here's an example response payload that you should expect back. That's kind of what they look like. And in the release candidate, we've tried to make it really easy for you to build those type of help pages. What we've done is we've created another service that you can grab from the config. It's an iAPI Explorer. And what this guy will do is it will give you a full runtime description of your Web API. All of the routes, all of the allowed HTTP methods for those routes. It will look for all the controllers, so it knows what the URI space actually looks like. It'll look at all the supported formatters. And it gives you this information and lets you can do whatever you want with it. If you want to serialize it to JSON or to XML and create your own metadata format, you can do that. If you want to create an MVC app that that uses that runtime data and builds a help page UI view, you can do that too. And that's what I've actually done in this demo app. Let me show you that working. Must have stopped it. I'll let the UI render again. OK. So you'll notice that there's this API link over here in the corner. And this is just going to link to an MVC view. And what it does is it grabs that API Explorer service, grabs all the API descriptions out of it, and then just renders them in a useful way. So here you can see, I can see all of the URI space. I can see what the HTTP methods are that are supported if I expand these things. And this is code I wrote. You'll want to probably have your API docs look the way you want them to. Like you probably want to skin them for your whatever branding you want. You'll want to add particular documentation in different places. The idea here is you have that complete flexibility. We give you the data, and you just write the doc however you want. We are planning on shipping some, like a sample NuGet package that will give you something like this. This code is available on the MSDN code gallery if you want to use this particular implementation. We hope to also provide a NuGet package that you can just download and install. But you can see here I get documentation for the actual action. I can get documentation for parameters. There's no parameters on this one. I actually wrote some logic that looks at the actions and looks at the formatters. And then I just gave it some sample objects and said, you know, if you return to contact, here's an example contact instance. And then I just take the supported formatters and serialize the sample object. And that's what I'm displaying here. It was a really simple way to just get some example payloads. And it knows about all the formatters, so it can show you example payloads in XML, example payloads in the vCard, electronic business card format. Let's look at another one. Here's post. So this has both inbound and outbound and parameters. So I can see that post is going to expect a contact. I can see the request formats. It exports JSON, XML, formula, encoded data, just like we said. On the outbound, you know, I can get an image back. I can get vCard back. Okay? So this is a useful piece of runtime infrastructure that you can use to build help pages. You could use it to build like little test clients if you want to allow your third-party developers to, you know, play around with your web API so they can learn how to use it. A lot of public web APIs have something like that. You could build that using this piece. If I show you the code and what that looks like, I just have my MVC controller. Controllers. Okay, here's my MVC controller. And there's the piece of code where I'm going into the configuration, and I'm grabbing that API Explorer service. And from the API Explorer service, I get all the API descriptions. Where am I looking at here? Yeah, here. API Explorer.API descriptions. And each of those API descriptions describes every API in your app. And then I just render it as some views. Okay, last thing is about hosting. There was that hosting block, if you remember in the previous slide, and that hosting block is responsible for actually producing the HTTP request message that Web API will use. Web API doesn't care what it's sitting on top of as long as you give it an HTTP request message, and it will return an HTTP response message. We support basically arguably three hosting models. You can host in ASP.NET. That's what you've seen me doing. We've wired up an HTTP handler that reads in the request, converts it to an HTTP request message, and then news up an HTTP server and pushes it up the stack. You can also write your own host. You can host web APIs in like, you know, a console app or a Windows service or an Azure worker role, for example. Other options, I mentioned earlier, you can just take the HTTP server and give it directly to HTTP client. You can host the whole stack in memory. You could put Web API on top of an OWIN bridge. OWIN is a specification for an interaction between a web server and a web application stack. And there's an OWIN bridge that someone wrote. It's out there on NuGet for Web API. And using that, you could put Web API on like a third-party web server like Kayak or Firefly. Let me show you an example of hosting in self-host. So here's a self-host sample. Okay, this is just a console app, nothing fancy. Here's my Web API controller. It looks just like an ordinary Web API controller. I derive from API controller. It has a get action. In this case, it's just returning a simple static string. Here's the program logic. I need to specify a base address, what I'm going to listen on, because I'm writing my own host here. For self-host, we give you this HTTP self-host configuration. This derives from HTTP configuration, has the same set of properties, formatters, filters, message handlers, but it also has the base address that you want to listen on. And then I set up my routes. Notice here I'm using full, what you would normally call ASP.NET routing, but within a console app. So we've actually taken routing and decoupled it from ASP.NET and enabled you to use it from any host that you'd like. So I set up my default route. There it is again, API controller ID. Okay, and then here's the actual host code. I knew up an HTTP self-host server with my configuration, and then I open it. And what this guy will do is it actually has a little tiny piece of WCF down on the bottom. It uses the HTTP transport binding element from WCF to actually listen. and it gets the HTTP request from WCF, packages it up as an HTTP request message, and from then on up, it's all Web API code. Okay, and then I new up a client. I call get. I'm going to say get the resource, and hopefully print it out. Let's see if it works. Okay, Web API started, Web API response, hello world. Cool. So it seems like it worked. In case you don't believe me and you think I just like hard-coded that in the console app somehow. Let's go localhost, I think it was 8088, API, hello, right? Request it. There it is, hello world. Okay, so that's Web API hosted in a, your own host. The other thing I'll show you is in my tests for Contact Manager. I do have a little test project. I have an end-to-end test where I test post, because post is kind of complicated. Like it was touching the response message, it's doing content negotiation, it needs the configuration, it needs a whole bunch of things. And so I decided I was just going to test it end-to-end. And the way I do that is I stub out the repository, I new up my own HTTP configuration instance, but I run it through my application's config logic. Like you remember I had this static class that took a config, right? This configure method in the web application. And here's where all my config logic sits for Web API. I think this is a good pattern. We use this pattern in our updated templates by the time we ship. So I can just recall this logic again from my test. So that's what I do. So I basically populate the config. I create my own HTTP server with that config. I create an HTTP client, and here's that trick where I take the server, it's just a message handler, I give it directly to the client. And I'm telling the client, don't use your message handler that uses HTTP web requests under the covers. Just call this message handler, call this HTTP server in memory, and it will run the whole stack up and down. So I can do a post, that will do connect, that will run my message handler, it will do the whole kit and caboodle, and I get my response back. So that's another way that you can host Web API completely in memory. Another cool scenario that this is useful for, we have people that are doing batching, where they have like a message handler that sits inside the stack, and then you have your request. As your requests come in, the requests are actually my multipart, and they have a bunch of HTTP requests embedded in them. Like there's actually a MIME type defined for an HTTP request, and so it's a bunch of HTTP requests. We support parsing that MIME and creating HTTP request messages from the initial request, and then you just new up a new HTTP server and pump the HTTP request messages up the stack as a sort of a simple way of doing batching. It's pretty cool. All right. Cool. The road ahead, we ship with MVC4. We are supported in .NET 4. We're in the box with Visual Studio 2012. We're in there in RC. The release candidate is available. You can get it via the web platform installer. You can get it via NuGet. You can get nightly builds from the Coplex site. You can just get Visual Studio 2012 RC. We are targeting RTM, Q3 2012. Because we're on the Visual Studio train, we're aligned with, all the other big ship vehicles at Microsoft, which I don't even know what the release date is, so I couldn't even tell you exactly what it is. But sometime in that time frame, we ship. So in summary, I hope you've seen that ASP.NET Web API is a great framework for building HTTP services. You can use it to reach a variety of clients, browsers, mobile, tablets, phones. It's a great platform for doing RESTful services. Why did it say MVC 5? There's a new version. No. Oh my goodness. It's not MVC 5, it's MVC 4. Wow. Yeah. ASP.NET MVC 4 release candidate. Try it out. You can get it off of the ASP.NET site, and follow us on Coplex. And here's a bunch of other related sessions you can go see about the ASP.NET stack. I will stick around for questions. Thank you, everyone, for coming. I really appreciate it. Thank you for using Web API.